Mm.
Okay, so does anybody want to do number 22?
Can you copy paste the problem?
Oh yeah.
Yeah, on the whiteboard. Thank you. Grayson, I just released the score to you, okay? You can find it in your
Okay.
email. Yeah, thank you.
Did anybody solve number 22?
How about I can present?
Okay.
So,
Go ahead, please.
so if the
Gilbert. Yeah.
side lengths are like A, B, and C, then A, B, A, C, and B, C are all integers, and so is A, B, C. But like A, B, and C, none of them are integers. And so that means and and since ABC and AB are integers, that means ABC over AB equals C must be rational. And by like the same logic, A and B must also be rational. And since they're not integers, they must have a denominator. So let them be alpha, beta, and gamma. So like since ABC and AB must be must be since ABC is an integer, this must be a multiple of beta times gamma, and the smallest such multiple is just beta times gamma. This is alpha gamma and alpha beta. Stefan, the letters A, B, C are already reserved for the side length, so we're using Greeks. Anyways, let me just do the and never mind. So like then since let's say we want to minimize alpha, so since it's an integer, it should be like 2, and then beta will be minimized by setting it to 3, and gamma, like, you can't, the minimum would in theory be 4, but then the first one would become an integer, so it can't be 4, it must be 5, so like, this just becomes 15 over 2, and 10 over 3, and 6 over 5. And the product of all of these, if you calculate it, is 30. So that's the answer. Yeah, I explained why they had to be rational.
Okay, this is basically the solution I did too. So can move on to if are there any questions? Okay, so we'll move on to number 24, I think. Yeah. So does anybody know how to do this one?
Copy paste the problem first. Thank you.
Okay, so Vincent can do the Vincent, can you do it?
Sure. Wait, okay, so how do I make it follow? Um, so 100 is 2 squared times 5 squared. And a million is 2 to the 6, 5 to the 6, which means there's 49 total divisors and there's 49 choose 2 total cases. Okay, and then um the greatest common factor is exactly 100. We can split this into two cases. Either A and B are both greater than 100, or one of A and B is 100. So, for one of them is 100, then the other can have 2 to the 4 times, the other has 2 to the 4 times 5 to the 4 more that it can have. This is 25 total divisors, but you can't be the same. So, 24. And then if they're both greater than 100, let's say A is 2 to the 2 to the alpha 2 to the alpha times 100, and B is 2 to the beta times, or 5 to the beta times 100. Then let's say then alpha can be anywhere from 1 through 4, beta can be anywhere from 1 through 4. You get 16 cases. 40 over 49 times 48 over 2. So then just put the 2, like, cross off. And then you get, this is an extra 3, and this is an extra 5, and you get 5 over 147.
Okay, yeah, that was the solution I had too. So are there any questions on that? Okay, then number 25. And let me,
Oh, oh, make sure everyone is following you. Because Vincent just presented, so everybody's following Vincent right now. Yeah, thank you.
okay. Does anybody know how to do number 25?
Yeah, I think Edward can present.
Okay,
Oh, okay, great. Um, oh, okay. So like we can imagine we have a circle, right? Here's a circle. So like we need to find the expected value of the square of the distance between 2 points. So assume one of the points is like right over here, I guess. And then like draw the radiuses. That's an arrow. Wait. Okay. So suppose like we have like one of these radiuses and maybe another radius as well. To our second point. And so let this angle here be a theta. Right? And so if it's random, this theta will uniformly have a uniform distribution from 0 to 2 pi. And so we need to calculate the distance, which is this length over here. Then we can use a law of cosines. And this length is 6, right? Okay, it's 6. So the length of this we can express using law of cosines, and so it's the square root of 36 plus 36 minus 72 cosine of theta.
right? Uh, of whatever that is. And then we can simplify this by and it asks us for the expected value of the square of the difference, right? So we need to find the square of it, which is simply 72 times 1 minus cosine of theta. Right? And so cosine of theta from 0 to 2 pi, the average of it is 0, so we can eliminate that term. And simply get the average as 72. So our answer is 72.
Yeah, so this is a good solution. And as Stefan mentioned, you can also just use coordinates. So, for example, wait, let me. So if you say the coordinates are x1 and y1, and then x2 and y2, then the distance, the square of the distance is going to be x1 minus x2 squared plus y1 minus y2 squared. And then you have, if you expand it, you have all the squares. And then you have this term. But because the coordinates are on a circle, so x1 squared plus x2 squared is 36. And this is also 36. So you have 72 minus 2 times x1, x2, and y1, y2. And because all the coordinates are independent of each other, the average of them is always going to be 0. So by linearity of expectation, this just becomes 0. So it's just 72. So you can also do it like that.
It seems Yichen also suggests another method, like about utilizing symmetry and pairing. Yeah, can Yichen also like
Yeah.
introduce your method? Yeah, thank you.
Oops. So like you can draw a diameter here. I'll just extend this and also
Oh,
connect.
oh, Yichen, let everyone follow you. Yeah.
Wait, shoot. Waiting for followers. What?
Okay. Yeah. Okay.
So you can just like draw like the diameter, and like here you have these two side lengths, and like you can like basically pair every single chord on the circle with another chord, and like the sum of their squares add up to 144. So like with this pairing, you just get the average just like 144 over 2, because like you have these two like chords that you can pair up, and like they average out to like 72.
Okay, this is also a valid solution. That utilizes symmetry. So are there any questions on any of the three methods? If not, then I'll do number 26. Okay, let me make. So does anybody know? No, did anybody solve this one? Does anybody other than Edward know how to do this? Okay, I'll just choose I'll choose Edward.
What is this targeting? Well, I didn't even like solve it, so trust. You shouldn't call on me. Or else like I might get the wrong answer, you know?
Okay, then I'll let Vincent do it.
Wait, I didn't even do.
Then I'll let Yi Chen do it.
Okay, I'll make this quick. Wait, but people might not know this like thing.
Yeah, I have
Whatever.
a
So this,
solution without characteristic equation, so you can do that too.
okay, so basically the characteristic equation for this is x squared equals 5x minus 6.
Wait,
It
quick,
basically
like
finds the
follow
fixed.
my view.
Oh, okay. So basically what this is that it finds the fixed points, and from there you can kind of like prove it. So you get that the fixed points are 2 and 3. And then you can basically express each term of AK as in a times 2 to the k plus b times 3 to the k, because 2 and 3 are the fixed roots or fixed points here. And from here, it's kind of easy to like, wait, like just like you have to solve this thing for A and B here. So you can like eyeball here that 2 is 1 plus 1 and 5 is 2 plus 3. So it's kind of like easy to guess here that A should be 1/2 and B is 1/3. What? And then if you plug this back in, you get AK is 2 to the k minus 1 plus 3 to the k minus 1. And then if you just plug this in here, you can just use it's like gonna be this over 6 to the k. And if you just calculate this out from here, like it's gonna be 1 over 6 times yeah, you just like calculate this out. 1 plus like 1/2 plus 1/4 plus so on. Then adding 1 and like 1/3 and so on. And if you just calculate this out, it's 7/12. No, yeah, 7/12.
Okay, so you can do this if you know characteristic equations, and it would be like faster, but if you don't know characteristic equations, then there's a solution. Like, does anybody know a solution without characteristic equations? Okay, I'll just do it then. So if you like divide the recursion by 6 to the n, then you have this is your recursion. Okay, and then you want to like relate this to what you need to find. So you can say that so this a to the 8 of n over 6 to the n minus 5a. This is just your like recursion. And this thing equals 0. So if you take the summation of this from 3 to infinity, then that should also be 0 because each of the terms is 0. And then if you split this, you can find each of the individual summations. And this would be 2 to infinity because you start at like it's a of n minus 1. And this one would start at 1 because it's a of n minus 2, and then you started at 3. And if you say what you want to find is s, then this thing is s minus a1, a2 over 36 and a1 over 6. And then the second term is 5/6 of s minus, because you don't have the first term when n is 1. So that's like a1 over 6. And then this term is just 1/6 s. And this whole thing equals 0. So now you can just calculate s. So you have s minus 5 over 36 minus 2 over 6 minus 5/6 s plus 5 over 18 plus 1/6 s equals 0. And you get the 1/3 s equals 7 over 36 and s equals 7 over 12. So this is a solution if you don't know characteristic equations. Are there any questions on that? Either of the solutions? If not, then we'll just do number 27. So does anybody know how to do number 27? Does Vincent know how to do it?
Wait, I can try. Do you like use coordinates?
I mean, yeah, like yeah, you can you can use coordinates.
Okay, that being said, you have a parabola. Oh my God. It's fine. And then you have, wait, hold up.
I'll draw it for you.
Wait, I can just draw it on the given diagram.
Okay, yeah, sure.
Yeah, and then so you have your 2 points here, you have 2 points here, and you have 2 points here. And this is, so let's say the x coordinate of this is x, like this point. Then this length is x. And in a hexagon, the main diagonal across is a 2x or two of the side lengths. So this coordinate is 2x. And then given these, you know the y, and the y is also root 3 over 2 of 2x, which is just root 3x, or the difference in the y between these two coordinates. So then so for wait, so 4x squared minus x squared, and then this is the difference in y. This is equal to wait, this is equal to the hexagon's this diagonal, which is 2x, yeah, root 3x. I think I have no clue. And then I think 3x squared is root 3x. And x is just well, x can't be 0 because then you don't have a hexagon, you just have a point. So x is a root 3 over 3. My handwriting is terrible. You have root 3 over 3, and then the area, you know the side length is 2 root of 3 over 3. And then hexagon is like 3 root 3 over 2 of the side length squared. The side length square is like 4 over 3. And then 3 root 3 over 2 of this is like 2 root 3. Yeah. So there's just 3 root 3 over 2 times 4 over 3, which is 2 root 3. Oh God. Hold up.
2
Yeah,
root.
that's basically what I did. So basically you have like you have one of the coordinates as like say a and a squared and like b and b squared, and if you can equate the sides and you know it's like a 30, 60, 90, so you can find that a is like √3/3, and then the side length is 2√3/3, and you find the area. So are there any questions on number 28? Or number 27? If not, we'll do number 28. Make it the So does anybody know how to do number 28? Or did anybody do number 28? Oh, does Grayson know how to do it? Okay. Does anybody else know how to do it? Grayson, can you present your solution? Okay, so I guess I'll do it then. If nobody knows how to do it. So first we can like simplify, so make x like make x a minus 1 y to be b minus 1, and z is c minus 1. And then so we can do like complementary counting. So for it not to be like, first of all, w log that c is the biggest one, and then we can multiply by 3 at the end. Like c is the biggest side length. So for it not to work, then c must be greater than a plus b. So z must be greater than x plus y plus 1. And the biggest value of z is 3, so x plus y must be less than or equal to 2, or less, strictly less, but it doesn't really matter. And then so it's gonna be like and then z will be all the remaining values like above it, above like x plus y plus 1. So it'll be like a tetrahedron. If this is your xy plane, and this is like x, y, and z, this 3, this 3, this 3. It will be like this tetrahedron when z is greater than x plus y plus 1. And the sides will be 2, so it'll be like 2, 2, 2, and so the area of that the volume of that tetrahedron will be the base is 1/2 times 2 times 2, which is 2, and then 1/3 times base times height. So the volume of that tetrahedron is 4/3. But then we have 3 because we said that like c would be greater than a and b at the start, but it could be like a could be the biggest or b could be the biggest. So you times that by 3, and the volume is 4 in total when it doesn't work, and the total volume is like 3 cubed. So take the complement of that, and that's 23/27. Are there any questions on that? I guess not. And we'll go on to number 29. Yep. So does anybody know how to do number 29? Anybody? Okay, should I cold call?
Yes. Go ahead. Do the code call.
Okay. Does Grayson know how to do number 29? Okay. Does Yi-Chen know how to do it?
Yeah, I'll just do it, I guess.
Okay.
So you can like change the equation or like move things around, move terms around.
Do like follow my view thing.
To get this. Wait, this is a y. And this should be equal to 108. So if you just graph this out, you'll get four circles centered at 9, 9. So now you need to find where they intersect the x-axis. So if you just solve the equation, you'll get that it intersects it like somewhere at like what? Wait, well, that's not a zero. What am I doing? Where is the eraser? So it's like 9 plus square root plus 3 square root 3, 0. So if you just keep drawing this like this, then you can also find here that um, like this thing, like this angle right here is 60 degrees. And then you can also like find the center here, like, and then doing. Wait, this graph is really terrible. I'll just like redraw it. So it's a shape like this. Oh, and you have the center here at 9, 9, and you have this is 30 degrees, also 30 degrees, and this is the right angle. So then you can find you can find like this angle, which is going to be 210 degrees. And then because you know the radius is 6 root 3, right? So then it's wait, did I get something wrong here?
Professor, each circle's thing is like 2/3 the circumference. Well, like the central angle is 210, but then you also have like this part, which is 30. So then it's 240.
Oh yeah, so that's gonna be 210. I also have like this part right here because if you like solve like the points where it meets the axis is, there's also like gonna be a 0 and 9 minus 3 square root 3 here. So then you can get that this is 30 because you can like use the triangle and side length ratios and then that's also 30. So you get 240. And then you just do this times 4 times 2 is the total of all four circles and then 240 over 360 and you get this is 32 root 3. Yeah.
Okay, yeah. So basically, you have oh, you have this circle centered at 9, and then there's two parts that you need to count. And then this is 9 plus 3 root 3 and 9 minus 3 root 3. So then this length is 6 root 3. And so, and the side length is also 6 root, I mean, the radius is 6 root 3. So this is like 60, and the same thing on this side. Get this 60. And so so the part you need to count is like 360 minus 60 minus 60. And so the angle you need to count is 240. And so 240 over 360, and then the circumference is 12 root 3 pi, and that's 8 root 3 pi, and then times 4, because you have 4 circles. So you get that 32 root 3 pi. Are there any questions on that? Okay, I'll go to number 30 then. Wait, let me get the thing. So does anybody know how to do number 30, or should I cold call?
Oh, I know how to do number 30.
Does anybody other than Vincent know how to do number 30? Does anybody other than Vincent or Yi Chen or like yeah, does anybody know how to do it? Or I guess I'll cold call on somebody if um I wanna call Stefan. Did Stefan do it? I guess not. So I'll just let Edward do it. Okay, now I'll let Vincent do it.
Okay. You take the height from D.
Follow your view.
Okay. You take the height from D on ADB. You get this triangle. You have root 21, and you have 2 root 3. It is definitely isosceles. Um, and this is root 9. which is also just 3. So this is 3. We have the base is ABC, and this is 4 root 3. And so the height is 2 root 3 times root 3, which is equal to 6. So the center is in the middle of ABC because everything's symmetric. At middle, I mean centroid, but same thing. You have 2, and then now we know that the height is 2. So we can take the cross section through CD perpendicular to AB, and we get this triangle. Wait, hold up. Yeah, this triangle. And you know this, and so if there was some sphere that fit inside the circle or inside the triangle, it would be, to maximize its area, it should be equidistant from all of these sides, BD, CD, and AD. So it would be on this middle point through this, oh my God, through the center of gravity. So then you know that the center is somewhere on here. So let's just consider this triangle. You get this triangle. This is 3. This is 2. Center is somewhere on here. So let's say this is x. The radius is x. Then the radius here to this side should also be x. And the side is just face ABD. And then these are similar triangles. You get 3 over 2x. And then 5 over 2x is equal to root 5. 5 over 2x is root 5. X is equal to 2 root 5 over 5.
Yeah, that's a good solution with similar triangles. But if you didn't want to use similar triangles, then you could use this formula. And if you didn't know the formula, then you could use Vincent's way to do it. But I guess I'll just show without similar triangles. So like for 2D triangles, there's a like the radius. Why is it so thick? The radius is the area over the semi-perimeter, and for 3D, well, like tetrahedrons, or like it's the formula is gonna be the radius. The in radius is 3 times the volume divided by the surface area. So you could just use that, and the area of the bottom, like the area of the base, is 4 root 3 squared times root 3 over 4, and that's 12 root 3, I think. Oh wait. Yeah. So, and then if you can use Vincent's way of finding the you can use Pythag to find the altitude for each of the other triangles, and it's 3. So the volume of each of the, I mean the area of each of those is like 3 times 2 root 3, which is 6 root 3, and you have 3 of those. So it's 3 times 6 root 3, which is 18 root 3. So the surface area is equal to 12 root 3 plus 18 root 3, which is 30 root 3. So that's the denominator. And now to calculate the volume, you can find the height. And the height is going to go through like the center of the base, as Vincent said. So you can, if this is your bottom, this is the base from top view. So the center is going to be like that. And it's going to be 4. And then you have this like height going up, and that it's going to be like it's going to be a right triangle, and so the height is going to be like root 21 squared minus 4 squared, the square root of this, which is square root 5. So the height is √5, and the volume is 1/3 times base times height, and the area of the base was 12√3. I think, yeah. So you have the height and you have the base. So the volume is 4√15. And then so if you plug it into the formula, you have real s, which is 12√15 over 30√3. So that's 2√5/5. So are there any questions on either of the solutions? I guess not. So I guess we'll be doing target now. Does anybody know how to do number 6 from the target? Here. Anybody other than Edward or Vincent? Who should I cold call? Did anybody other than Edward or Vincent do it? I'll let Edward do it then. Oh. Then I guess Vincent can do it.
Oh, okay. Then one of these is divisible by 2 and one of these is divisible by 3. If this one's divisible by 2 and this one's divisible by 2, then one of these is divisible by 4. But if any of these are divisible by 4, also, if any of these are divisible by 4, then the remainder, then if it's a prime, you need two primes multiplied together, but the remainder is 4 mod 24, so there's always a factor of 4, which is not good, which means that n plus 1 is the one that has a factor of 2. However, if n plus 1 is also the one with a factor of 3, then the only way it'll work is if n plus 1 is 6, because anything afterwards will have an extra factor of 6 with something else. And 5, 6, 7 does not work. No. So we can do casework on n and n plus 2 being multiples of 3. If n is a multiple of 3 and n plus 1 is a multiple of 2, n plus 1 also cannot be a multiple of 4. So 3, 6, 9. Also you can just disregard 6 because it's even, disregard 12 because it's even, disregard 18 because it's even, and then you're left with 3, 9, 15, and 21. This one makes it divisible by 4. This one makes something divisible by 4. And these two, if you test enough, they do work. So now let's do cases on whether n plus 2 is a multiple of 3. We have 1, 4. Wait, this is the values of n. So 1, 4, 7, 10, 13, 16, and 19. And again, n plus 1 cannot be a multiple of 4, and it has to be even. So bam, bam. and these two work. So your final result is 9 plus 21 plus 1 plus 13, which you get is 44.
Yeah, so that's pretty much the solution I did. Just like casework and get those values. So, are there any other questions on this? I guess we'll move to number 7 then. Oh, let me get. Does anybody know how to do number 7? Anybody other than Edward? Did anybody other than Edward do it?
Oh, it's already 9:07. So let
Okay.
Edward present
Already
it.
saw Edward. Okay.
Yeah, if later you find out that your method is different from his, you can also present your method. Yeah.
Yeah, okay.
Okay, thank you.
Looks like I'm doing this problem. Okay then. How do you do this problem? It's actually quite simple. So it requires you to know how a net of a cone works. Looks. So basically a net of a cone looks like a circle with a sector. That looks terrible, but okay. So first of all, we need to calculate, so like we don't have a base, right? So we only have a sector. So let me draw a little better sector. Okay, that's good enough, I guess. Actually, I think I need like a slightly better one. I cannot draw with a touchpad. Okay, so here's our sector. And now we have points P and Q. Cannot write. Uh uh not P, that's a P. Suppose I have points P and Q. That's the question, right? It's huge. Okay. So it gives us in the question that they're 150 degrees apart, and we know the radius is 3, right? So the length of arc PQ is I think it's 150 over 360 over 5 pi, right? Over 6 pi. So diameter is 6, right? So this simplifies to a 5 over 2 pi. Okay. So this is 5 over 2 pi, right? And then we need the radius of this sector, which is also known as the slant height of this cone, which is this length over here. And we can use Pythagorean triples to find out it's 5. So over here, the radius here is 5. And it's basically unimportant of how large the sector is or what angle the sector is, so we can ignore that for now. The main thing that we care about is that this arc is 5/2 pi. That's not 5/2 pi. And so the full length of the circle is 10 pi. So it must be 25% of the circle. So this is 90 degrees. So we draw a nice line, and then we get this is 5√2, which is okay, which is 5√2. Oh yeah, we need a decimal, right? It's 7.07 as far as I know.
Okay, yeah. So basically you just need to know that like you can unwrap a cone into like a sector, and then you can like use arcs and find it. Okay, does anybody know how to do number 8? Did anybody solve it? I guess I'll just do it myself. So basically, so first we say that like the roots of f of x are r and s. So then when you have like when f of r, so the roots, so there's gonna be 4 roots because it's a 4th degree, and there are 2 quadratics, these two, when f of x equals r and when f of x equals s, and the two roots of each of those, and we know that -1 is the only real root, so one of them must have -1 as the double root, so just say that one's r, and the other one has complex roots. So f of x equals r, that's like x squared plus ax plus b minus r. And if the roots are x, or if the roots are x minus 1, then it's going to be like x minus 1 whole squared, which is x squared minus 2x plus, or x plus 1 whole squared. So that's x squared plus 2x plus 1. So now you know that a is 2 and b minus r is 1. So now we know this, right? And then, and we can say that r is b minus 1. So, but we also know that f of r is 0 because it's a root of f of x. So from f of r equals 0 and r equals b minus 1, you can like expand the quadratic. So we get r squared plus 2r plus b equals 0. And if you substitute the r's for the b's, you get a quadratic for b. And from the quadratic formula, you get the roots are -1 plus minus root 5 over 2. And so this is what you get when you do r. But now from f of x equals s, and these are complex roots, the quadratic is x squared plus ax plus b minus s equals 0. And because they're complex roots, the discriminant must be less than 0. So that's like 4a minus 4 times b minus s. And because a is 2, so we have a minus, oh, this should be a squared. Yeah. So that's, we know a is 4, right? I mean, a is 2, so a squared is 4. And so this is less than 0, because that's a discriminant. And so you get that b minus s is greater than 1. And so s is less than b minus 1. And so we can use that to figure out whether whether b is positive or negative. Because from Vietas, because R and S are the roots, we have RS equals b, because that's Vietas, the product of the roots. And we know that R is b minus 1. So S equals b over b minus 1. S equals b over b minus 1. And so this is only going to be less than b minus 1 when b is positive. So we know that the value of b is root 5 minus 1 over 2. And now we can just we have f of x because we have a and b. And so now we can just find what do we need to find again? F of 1. So now we can just like do it. And f of 1 is 5 plus root 5 over 2. And you, after expanding, you get 12 plus 4 root 5. So are there any questions on that one? It was a bit long.
Oh, thank you, Om. So we finished all the problems, right?
Yeah.
This is the last problem. Okay. Yeah, you did a great job. Yeah. And also, yeah, and I think this coming Saturday we will have the chapter round. Yeah, at the Harker Middle School. So, are you guys ready? It's only chapter round. We have been practicing for like almost, I think at least 5 weeks, and we were using the national exam, MassCon national exam, much harder than the chapter round. So when you guys, take the chapter round at Harker, you guys just need to calm down and make sure don't make silly mistakes, okay? And since it's only Wednesday and still a couple of days to go before you guys take the chapter round, I will assign some like a state round test, maybe just a few of them, like through the Alpha Star training platform. And yeah, if you have time, you can work on them a little bit easier than the MassCon National. Yeah. Okay, thank you everyone, for joining this practice session tonight. And you guys did a very good job. And I really encourage you guys, yeah, some of you guys did very good. Did very well, like, contributing your method and yeah, sharing your solutions. Yeah. So I encourage everyone next time, like, yeah, like next time, like, you just share your method. Yeah. It doesn't matter if it's the complicated one or yeah, you can share some of your ideas and then maybe, maybe you didn't figure out the rest, but let other students to help you figure out the rest. Yeah, because everyone has his or her own like, style of solving the problem. So yeah, so don't be afraid to, to present your solution or even simply just your idea. Yeah, we can work together to figure out how to complete it or how to finish the solution. Okay, then let's call it a night. Let's call it a day. And so yeah, later I will share the recording with you guys and also assign a few tests, a few assignment to you. And yeah, keep practicing. Okay. Yeah. Good luck on the weekend chapter round. Then bye, everyone. Bye. Thank you.
Thank you.
Thank you. Bye.
Bye.